Okay. Assalamualaikum warahmatullahi wabarakatuh. And a very good morning. Uh, we meet again in our kuliah. I think as our previous kuliah, we already discussed about chapter 5, which is the deflection of the beam. And we managed to calculate it with using very simple mathematical expression. Of course, on that chapter, they really utilizing the double integration method in solving the problem. Therefore, of course, it be expected for the student to understand on how to solve the problem. Okay, so that's one of the recap for chapter 5 on the last previous lecture. So for today, it's going to be the last chapter for the entire uh, syllabus. This is chapter 6, where we're going to study about the shaft, more or less, a shaft that been subjected to a torsion kind of load. You know, shaft tu dia macam ni shaft dia berpusing. Dan just imagine berapa torque, berapa torsion yang boleh membuatkan dia pusing, yang mengakibatkan berlakunya tegasan atau berlakunya stres yang dipanggil shear stress. Okay. Sama juga macam bending moment. For this case, for this case, shaft ni dia ada pelbagai, apa kita panggil, dia ada pelbagai formula untuk kita selesaikan, tapi the most important formula is this one. Buat kejap. The most important formula is this one. Okay, this is important formula yang kena hafal. Kita kena hafal, kita kena faham, dan we need to understand, we need to kind of like memorizing the formula. Okay, the formula for the first thing first, saya padam dulu supaya awak faham. This formula is consists of, okay, ini yang pertama, expression pertama. Awak tengok simbol macam T ni sebenarnya ialah tau. Kita panggil dia tau. Ni ialah tau. This one we call tau. Okay. Tau ni ialah daya receh. Kalau tak percaya, tengok. Nak kira stres ataupun tegasan receh maksimum. Kan dia ada tegasan receh. Dia ada tegasan ni saya rujuk balik to make it confirm. Tapi nama ni panggil tau lah. Okay. Betul. Shear stress. Betul lah tu. Ini dipanggil sebagai shear stress. So, yang bentuk macam T ni, the one that look like a T, basically it's not a T. Dia tau kan. Dia macam ni, and then dia macam ni. This one we call shear stress. Okay. This one we call shear stress. Shear stress ni definition dia is the shear that occurred, the occurring shear during the torsion process. Contohnya kalau kita pusingkan ni, kita piuhkan dia, then akan berlaku stresses. Stresses tu dipanggil tau. Okay, unit dia ialah macam biasa, MPa. Okay, Bukanlah MPa, means M tu dia punya magnitude atau skala. 10/6 Newton per millimeter kuasa 2 ataupun Newton per meter kuasa 2. Okey. So itu ialah tau. Okey. Manakala untuk kes yang untuk terma yang seterusnya, okey, R. R ni ialah radius. Di mana unit dia ialah sama ada milimeter ataupun meter. Okey. So inilah persamaan yang pertama. Yang perlu awak tahulah. Okay, that you have to know clearly. So then I move on to second expression of the equation. Beforehand, I need to delete this one first. Okay, just give me a minute. So kita dah selesai yang itu. So then we go for another one. Okay. Alright. Okay. This one. Our second expression. What does it mean by that? Okay. For our second expression, we need to know that ini ialah dipanggil theta. Theta ni ialah sudut. Let's say bila benda ni berpusing, just imagine benda ni berpusing daripada point A kepada point B. So awak akan tengok dia akan wujud yang kita panggil satu sudut. Sudut piyuhan ataupun bahasa Inggeris macam mana? Dia panggil sudut piyuhan lah. Inilah dia. Ya. Theta tu. Okay. Itulah dia sudut piyuhan. Kalau kita rujuk terma dalam buku, entah angle of twist. Dia panggil angle of twist. Angle of twist biasanya dia punya unit ataupun dia panggil radian. Rad. Therefore orang tahulah macam mana nak convert angle to rad. Dia ada pi over 180 dengan 180 over pi. This one I think you already covered. You already covered it during your first or second semester. So inilah dia. Angle of twist. Twisting angle, sudut piyuhan. Bila dia pusing daripada point A ke point B, dia akan ada satu dipanggil sudut, which is biasanya kita kenali sebagai sudut yang dipiyuh. Okey. Manakala sebentar manakala untuk untuk G ni ialah kita panggil Bach modulus. Bach modulus ni dia macam Young's modulus lah. Tapi Young's modulus gunanya untuk elasticity yang dalam keadaan lateral. Yang dikenakan daya yang vertically ataupun horizontally, yang menegak atau melintang. Tapi kalau ada melibatkan elemen pemusingan, kita tak boleh pakai Young's modulus. Kita kena pakai elemen Bach modulus. Kalau Bach modulus ni dia ialah G. And then dia punya unit masih lagi sama, iaitu GPa. G ni dia punya vektor magnitude skala lah. Dia boleh jadi kilo, dia boleh jadi giga, dia boleh jadi mega. Tapi yang paling penting sekali ialah dia Newton per meter kuasa 2 ataupun Newton per milimeter kuasa 2. Alright. And Last one, L ni ialah length. Length of the structure tu. Dalam bentuk meter ataupun millimeter. Okay, this is our second expression, which is somehow you need to understand lah. You need to know. Okay. So before I proceed to our third expression, let me padam dulu supaya tidak mengelirukan dan mudah nak difahami. Okay. Then kita pergi kepada our third expression lah. Our third expression is this one. Okay. This is the third one. The third expression more or less dia ada T. T ni apa? T ni ialah torsion. Torsion. Berapakah magnitude torsion yang dikenakan? Let's say kalau dia dikenakan dengan apa tu, kalau torsion tu dikenakan dengan dayanya, iaitu dia boleh jadi, saya tengok unit, kadang-kadang lupa unit, tak boleh ni. Newton meter. Ya. Tidak sama tu. Dia ada Newton meter. Ni torsion. Okey. Maksudnya dalam arti kata lain, ni contoh, ini ialah struktur awak. This is your structure. So just imagine that it been clearly dikenakan daya. Macam ni. Dia pusing. Torsionnya mungkin something, let's say 5 Newton meter. Jadi yang paling penting sekali, kalau nak tahu, kejap angle of twist dia ialah ini. Inilah angle of twist dia. Inilah torsion yang dikenakan. Okay? Kita dah belajar berkenaan dengan torsion. And then lastly, kita pergi kepada J. Kalau J ni nama dia second polar moment of area. Second polar moment area. J. Dia punya unit ialah saya padamnya. Dia punya unit adalah meter kuasa 4. Of course lah, J ni dia ada formula di sini. Nanti kita akan tengok lah. Ni contoh antara formula J lah. Okay. Of course lah, each of it ada formula sendiri. Biasa J lah. J ni dia macam I lah. Kalau untuk kes yang sebelum ni, dia macam I. Manakala G ni dia macam E. Okay, so inilah 3 formula ataupun 3 expression yang boleh digunakan untuk solve the formula. Okay. How to tell? Ada part of it, ianya boleh digunakan secara berpasang. It can be used as couple. Okay. The first expression to the second expression. The second expression with the third expression. Or else the first expression with the third expression. No problem. As long as it fits to the problem, then it can be used. It's solvable. Dia boleh digunakan untuk menyelesaikan masalah tu. Itu antara sedikit sebanyak teori lah yang kita belajar untuk chapter 6. Dan ada tambahan sikit lagi teori yang benda ni sipil lah, kena faham. Okey. Kita pun tahu bahawa shaft ni it can be made in two condition or in two forms. Okey, first kali ialah series shaft. Series shaft ni maksudnya dia berbentuk series. Dia boleh jadi dalam macam keadaan A, B, and then mungkin boleh besar sikit ke C. So dia ada A, B, C. This one is series shaft. Ataupun shaft yang berseries. Okay. Manakala parallel shaft ni biasanya dia panjangnya semua sama. Tapi dia ada hollow. Macam tu. Jadi kita tahulah. Ni shaft A, yang ni shaft B. Hollow tu mungkin ada masuk shaft ke, dia ada insert shaft ke, atau kadang-kadang jarang lah kita tengok problem yang macam ni. Satu, we got one shaft A, and then we got B shaft. And then they attach together. Ni jarang nampak lah. Biasanya yang ni. Okay. Biasanya yang ini. Okay. Masing-masing ada kelebihan dan masing-masing each of them got their own what you call that? Got their own advantages and somehow of course their own limitations. So this is formula to solve the problem. For the series shaft, we got two kind of formula in order to solve the problem, which is torsion. For the torsion, supposedly torsion yang berlaku di A, P1 is supposed to be equal to T2 and T3. They supposed to be equal. Begitu juga dengan keadaan angle of twist. Bila dipusingkan dekat sini ke atau dekat sini ke, angle of twist is expected to be sama. Bertambah. Ni bertambah. Okay, angle of twist dia bertambah. So, dia makin mencapah lah. From point A, maybe 5 degrees or 5 radian. Point B, it might going to increase to 8 radians. And point C, dia pergi kepada 10 radian. Sebab due to the differences in term of configurations or size. Okay, maybe A, dia punya diameter dia mungkin 5, B, diameter dia mungkin 3, C, diameter dia mungkin 20. Therefore, bila dia dikenakan daya kenakan and so on, dia punya angle tu begitu besar. Okay. Sama juga dengan parallel shaft. Okay. Dia punya angle pula. Dia punya torsion pula. Torsion dia bertambah. Means T1 campur dengan T2. Okay. Manakala angle of shaft dia sama je. Sebab dia tidak ada perubahan sizes. Continually ada perubahan size. Dan all about the equal length tu dia tetap sama. So ni dua perkara yang you guys need to know. Perlu tahu dan perlu faham lah. If not, then akan ada masalah lah untuk menyelesaikan chapter 6 ni. Somehow chapter 6 very what you call that? Very straightforward, very clear cut. Tak susah mana lah. Memang tak susah pun. Dia macam bab 1 je. Okay. So, the theory is there. Dah cover teori. Now, kita pergi kepada example. Much more easier. Okay. Example is very clear. Here I already drew a shaft here. Very clear shaft. Okay, shaft ni dia ada kepanjangan berapa? 750 mm. The shaft have a length of 750 mm. Of course, before solving the problem, we need to identify what kind of shaft it is, what type of shaft. Okay, to my observation, this shaft is a parallel shaft. It's a parallel shaft. Okay, and the shaft is been made up by what? Maybe a steel material, and it got a dimension of diameter out of 150 millimeter, and diameter in is 100 millimeter. Means the shaft is hollow. It got what you call that? It got lubang, and dia ada lubang kat tengah. It's a hollow shaft. Alright. Therefore, based on all the information given, so we need to solve this kind of problem, which is G, or the bulk modulus, is 80 gigapascal, and the maximum of tau shear stress, the maximum of shear stress is 75 megapascal. Therefore, the question is, how much the torque, or what is the torque? How much is the torque to support that can withstand with the maximum of shear stress about 75 megapascal? Berapakah daya receh yang perlu atau yang mampu untuk support atau compensate dengan shear stress yang maksimumnya mempunyai magnitude sebanyak 75 megapascal. So inilah what you call that, shear stressnya. Okay, so of course dia berikan power. The power is N ni, kalau dalam kes ni, N ni power tau, pusingan. Power, berapakah power sekiranya dia dipusingkan sebanyak, or shaft ni bekerja sepanjang masa dalam lingkungan 1200 RPM. Rotation per minute. RPM ni maksudnya rotation. Ni RPM ni maksudnya rotation per minute. Okay. For the case, let's say we presume the shaft is working, it is being used as a shaft for power supply, and then standard operating hours for the shaft is about 100, 1200 or 1200 rotation per minute. So what kind of power that it can generate? And then, of course, the third question is, what is the angle of twist during this all the operations happening? Berapakah daya piuhan? Lepas tu, dia kenakan segala perkara tindakan daya ke atas ni. Okay, so of course, using this kind of formula, and then since it's a parallel shaft, kita gunalah ini. Alright, so let's get moving to solve the problem. Saya turun ke bawah. Okay, to solve this problem, kita kena tahu dulu. Kita kena cari apa dia. Kita kena cari J untuk problem ini. Untuk problem ni kita kena cari J. So formula J, okay. J tadi apa? Second moment of, apa tadi? Second polar moment of area. So untuk J ni kita tahulah J ni hollow kan. Jadi formula dia ialah pi d power of 4 over 32. Ni formula J. Okay. Pi d power of 4 over 32. And since the shaft is hollow, so we know that we're going to what? We're going to subtract or minus between the the diameter in order to get this area. Nak dapatkan area ni kita kena tolak lah. Okay. So this one is diameter out and this one is diameter in. Okay. So once we insert all the numbers and then we manage to get what? We manage to get the J magnitude to be 3.988 power of -5 meter power of 4. This is nilai yang ada. Okay. So kita dapat J. Now, we back to our problem. What is our problem? We want to know what is the torque. What is the torsion magnitude? Okay. So I scroll down a bit here. We use this combination of formula, which is tau over J, torsion over J equivalent to tau over R. In order to get R, we use a maximum radius. What is the maximum radius? Let me clear this one first. The maximum radius is T out here, 150 millimeter. That is the maximum radius. No, that's the maximum diameter. In order to get the radius, you have to divide it by 2. Diameter over 2 is equivalent to radius. Okay. And then, in order to solve the problem now, give me that. Okay. So, this is the formula. You have to rearrange. Of course, in order to get T, you have to, switch this J to the other side. So, this is the formula, the whole formulation arrangement. So, T is equivalent to tau max multiplied by J over R. Or it can be this way lah. Alright. So, insert all the equations. Insert all the magnitudes. Okay. As we know, tau max is 75 megapascal. Okay. Divided by R is 75 millimeter. And then multiply by J, which is 3.988 power of -5. All around, we managed to get the torsion or the torque is about equivalent to be 39 kilo pascal. This is the maximum torque that can be happening with maximum torsion with maximum shear stress of 75 megapascal. So this is the maximum torque. Okay, around 39 kilo pascal. Okay, so we're going to solve our third problem, which is what is the power for this case? Beforehand, we know power, for the formation of power is like this. This is the equation of power. So we got torsion. This one is torsion. This one is torsion. Multiply by 2 pi n power divided by 60. Yeah, 2 pi n divided by 60. Since we know that n is equivalent to uh, rotation per minute. Okay, so that's why we got 60 here. So let's say if the case goes by maybe go by second, maybe it goes by hours, something like that. So you need to convert it to be RPM in order to suit for this equation. Yeah. So simple equation, just need to insert all the value required. Therefore, for this case, torsion is equivalent to 39 kilopascal, and then it goes along with 2 pi over n, which is 1200 RPM or 1200 RPM, and then divided by 60. So for this case, I think I managed to get 5011 kilowatt. That's the maximum power that it can what you call that it can generate from the whole operation. You know, for example, let's say this is the shaft. Okay, for example, this is the shaft, and then let's say it rotates, the pusing, by 100 by 1200 RPM, then the maximum power that it can generate is about 5011 kilowatt. It's quite a lot, to cover a good grid of electricity. All right. So now we manage to solve part A and part B. And this one is part B and part A. We managed to solve it. Okay. Other than that, we're going to solve for part C. Okay. For part C, it's a very simple one. The formulation for angle of twist is theta is equivalent to T multiplied by L and divided by G. Therefore, T is torsion. We know torsion is 39 kilopascal. This one is torsion. L is 750 millimeter. J is 3.9. This one is J lah, we know. And then G is part modulus. We know it give us the value of 80 gigapascal. Therefore, the radian or the angle of twist is about 9.375 power of -3 radian. Okay, and then a standard formulation from radian to angle. Okay, you have to multiply it by 180 divided by pi. So therefore, you got like 0.55 degree. So what does it mean by here is, let's say this is your shaft. Okay, this is your shaft. Let's say it 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 twists, and then the angle is about 0.55 degree. Once it been, let's say it been dipulaskan, maka angle dia ialah 0.55 darjah or degrees. 0.55 degree atau 0.55 darjah. Okay, so that is our first question lah. In order to solve it, now I go for second question. This one is a series shaft. Very interesting question. Basically, it's not particularly a series shaft. It's a combination of uh, series shaft plus with parallel shaft as well. Why? Since we got here supposed to be parallel, okay? Because it consists of two shaft with equivalent length, something like that. But this is not a problem as well. Very easy to solve, no problem, as long as you know the concept and you know what kind of equation that you need to use in order to solve the problem. Okay, just imagine here, we got an aluminium shaft, a solid aluminium shaft with a diameter of 22 millimeter, and then it goes with the bulk modulus of 36 gigapascal, okay, and uh, the length of 150 millimeter. While the other part of the component is we got a hollow shaft made by steel. Okay, since it's hollow, then it got uh, internal diameter of 5 millimeter, and then uh, outer diameter of 10 millimeters. Made by steel, therefore the bulk modulus of steel is 80 gigapascal. Okay, at this point, the shaft, the hollow shaft, been subjected to a torsion of 3 kilonewton meter. Of course, it got the length of 280 millimeters. All right. In order to solve the problem, a very simple expression, as I told you before, we solve the J. We solve the J first. Okay. How many J we got? We supposed to get 2 J's, since we got aluminium and we got steel materials. Okay. For aluminium, we know that the diameter of aluminium is 22 millimeter here. So just insert it into the equation and we managed to get G for aluminium is 2.3 power of negative 8 meter power of 4. Okay. Yet for the steel, since we already knew that is a, what you call that, is a show, the shaft is hollow, you know, dia dilubangkan di tengah, it's a hollow shaft. So in order to solve it, you have to subtract between the diameters. Therefore, by doing that, so we managed to get the steel. The J steel is 9.203 power of negative 10 meter power of 4. Okay, so this one, J for this one done, and J for this one already done as well. Okay, all right. So we go by a series shaft. Okay, a series shaft means what? The torsion have to multiply by each. Here, the torsion need to be multiplied by each, while the, what you call that, the angle of twist is equivalent. Okay, so let's switch it. Let's check. Okay, series shaft is here. Separate shaft, Okay, in order to solve it, in order to solve it, we need to go by, dia suruh cari apa? Dia suruh cari calculate T of each shaft. Calculate T of each shaft. Here. Therefore, just going to use this equation. Wait up. Okay, this equation, theta is equivalent to torque multiplied by L over Jg. Okay, this is standard formula for theta. And then, of course, we know theta aluminum is equivalent to theta steel. So, we rearrange it. So, we got here. Okay. So, let's say, katakanlah kita nak memusatkan untuk aluminum ni macam mana. Then, we arrange it this way. And then, we manage to get torque for aluminum is equivalent to 15.16 15.16 multiplied by torque by steel torque. Okay. To solve it, torque aluminum plus torque steel equivalent to torque total. Okay. So you going to arrange it this way. We know torque aluminum is what? 15.16. So we got 2 torque steel here. So the next simple mathematics, something like that. So at the end of the day, we managed to get torque steel to be 185.64 Newton meter. And then, of course, we use this number to equate in this equation. And then we going to find torque aluminum equivalent to 2814.3 Newton meter or 2.8 kilo Newton meter. Alright. So that's the thing. Of course, I think some of you going to confuse why I'm using this kind of equation, since this equation is somehow fit for parallel shaft. Right? Parallel shaft is the torque is plus to each other. Right? Parallel shaft, the torque is supposed to plus on each other. Yeah, I'm going to check back, but I believe this is the way to solve it. In a way, that's it from me. I'm going to explain it more during the face-to-face class after, yeah. So that's it from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you.